Hello guys, my name is Uğur and today we are going to learn what is REST API. Smash the like button if you like the video and drop a comment down below. Let's get started. First of all, let's talk about what's an API. API stands for Application Programming Interface. It's a set of rules that allows one software application to interact with another. Its purpose is to communicate between different software components. To make it easier to understand, let's think about the relationship between a customer, a waiter, and a chef in a restaurant. When a customer wants to order something, they call the waiter and tell them what they want. The waiter then takes the order and tells the chef what the customer wants. Once the chef prepares the order, the waiter brings it to the customer. In this scenario, customer represents the client, the waiter represents the API, and the chef represents the server. The API waiter provides communication between the client and the server. Now let's talk about the REST API. REST API stands for Representational State Transfer. It is an architectural style for designing networked apps. Introduced by a guy named Roy Fielding in 2000, its purpose is to simplify and standardize web service communication. REST API principles. Let's talk about the REST API principles. First, stateless. It means that every request from a client to server must contain all the information needed to understand and process the request. Its benefit is simplifies the server by avoiding session state management. If we talk with the concept of customer waiter, every time the customer orders, they tell the waiter exactly what they want without relying on previous interactions. On a RESTful API, each request from the client to the server must contain all the information the server needs to fulfill that request. This simplifies the server's design since it doesn't have to remember the client state. Client server. In other words, separation of concerns. The client handles the user interface and the server handles data storage and business logic. The customer and the kitchen are separate entities that interact with the waiter. The customer focuses on eating the meal while the chef focuses on cooking. Cacheable. This means that responses must define themselves as cacheable or not to improve network efficiency. This reduces the latency and server load. Let's give an example for our restaurant. If many customers order the same dish, the kitchen might prepare extra portions and advance to serve them quickly. Uniform interface, a consistent way to interact with resources, typically using HTTP methods. If we want to exemplify according to our example, customer always gives their order to the waiter in a consistent manner, and waitress always brings the food in a standard way. Now let's talk about the HTTP methods. HTTP stands for Hypertext Transfer Protocol. It is the foundation of any data exchange on the web. Get retrieves data from the server. Post submits data to the server. Put updates specific data in the server. And delete removes a resource from a server. Let's talk about what is a JSON. It stands for JavaScript Object Notation. It's a lightweight data interchange format, accepted by almost every programming language and framework. Its usage is very easy and very human readable. It is consisting of attribute value pairs, commonly used in web APIs to send data between a server and a client. Now let's implement a simple web API with .NET. Okay, now let's implement a web API project, create new project, ASP.NET Core Web API, ASP.NET Core Web API, this one, and name simple API. Okay, when we run our application, we are going to see a Swagger page. Swagger is a tool for making requests without a front-end application. We are going to use it in our project. Let's see our Swagger page. Okay, this is our Swagger page. We can see our HTTP methods in our Swagger page. Let's close it for now. Okay, as I mentioned earlier, an API is a program that provides communication between a server or a database and client. We can think that our client is our Swagger page, but we don't have a database. Let's create an in-memory database and store our data in our in-memory database. In-memory database is a fake database. When we run our project, our database is created, and when we stop running, our database is deleted. We need to download a package to create an in-memory database. Let's click our project and click Manage NuGet Packages. Click Browse Packages, and then we need to write Entity Framework Core in-memory database. Install this package. Okay, it's installed. Close window. Before creating our database, we need to delete the weather forecast and weather forecast controller. This is an example project that .NET provides us. Okay. Uh, let's create an class named user. Think about that is a database table. Uh, we need to store our data in a table in our database. And this class attributes are the table's columns. If we type prop in .NET, it can automatically convert it to a attribute. Let's call this ID, string name, string surname, email, and password. Okay. Okay, we create our first entity. It has ID, name, surname, email, and passwords. Now let's create our DB context class. Add new class, app DB context. DB context is like a bridge between your .NET application and the database. It helps your program talk to the database and manage data. With DB context, you can save, update, delete, and retrieve information from your database easily. It's going to inherit from DB context class. Context. This is a class that we downloaded. It came from this package, this Entity Framework Core in-memory package. Let's give our entity to our database DB set users. Now let's create a method named it's all right on configuring. It's a configuration method. Options builder dot use in memory database. We are saying that we are going to use in-memory database in our application. Database. We need to insert our DB context class to our API. We are going to do it in our program CS builder.services dot add db context, our db context. Okay. Now it's time to implement a controller. Right click the controllers folder and create a new controller. Let's give a name, user controller. This method. We need to say that that is an API controller. And let's give it a roles controller. Okay. Now we need to define our DB context here. Read only app DB context. Now let's create a constructor. If we write CTOR in Visual Studio, it's automatically converts to a controller constructor. Give it a parameter appdb context our context is came from this context. Okay, so we do not create any instance of this controller or our db context class. So how this constructor in the controller works without explicitly creating an instance of the controller or db context class? This is due to the dependency injection, where .NET Core automatically provides the necessary dependencies when the program starts. So even though you don't directly instantiate a user controller object, .NET Core does it for you, ensuring that it has everything it needs, such as appdb context. After the constructor, let's create our HTTP methods. HTTP get, I'm going to start with get request, public async task a action result. This is the base return type for controllers. Gets all users. It has no parameter. Return OK. Our context dot users dot toList. Okay, this is our first method. Let's create our second HTTP get. But this time we are going to take an ID as a parameter. Public async task by action result get user by ID. This integer ID parameter. It's a user. Let's use it as rate context dot user dot find async ID. If our user object is null, we are going to return not found. If the user is not null, we are going to return our user. Let's create our HTTP post methods. Public async task action results creates users. Its parameters are int ID, string name, string surname, string email, and string password. Await context dot user nokta at async new id equals id, name equals name, surname equals surname, email equals email, password equals password. In here, I write new and I didn't give a type like user, new user. I can do it like that, but we can give here only user, so the Visual Studio understands it and it gives us it that doesn't give us any errors. And we are going to return okay. And don't forget to save our DB context, save our database. Let's create our HTTP delete list. It needs a parameter ID. This is the ID that deleted user. Public async has action result delete user int ID takes a parameter named ID. We need to find the user first, not like this. First or default async. This is the correct way. We are going to write a lambda function here. Dot ID equals ID like this. Dot ID equals ID. ID. We need to put await here because it's a async function. And then if our user is null, we need to return not found because it's not a user object, user entity in our database. If it's not null, users of the remove user, and we need to save our changes and return OK. That's our controller. Now let's try it. Let's run our application. Here are our HTTP methods. Let's try the get method, get all method. Execute. As you see, there's no entity because our database is empty. Let's create an user name. Uğur. Email.com. 2, 3, 4, 5, 6. Execute. We get response code 2200. Let's execute this. Oh, we can see our entity here. And if we search by ID, we can get the same result. Let's create another one. Six, 5, 4, 3. Execute. Let's get all. We can see our two entities here. Let's delete one. Let's delete the second one. It gives us 200. If we type 2 here, I'm going to get not found because we deleted it. Let's see, get all. There's no second one. Okay, that's all from me, guys. Thanks for watching the video. If you like it, drop a like and drop comments down below. Thanks for everything. See you in other videos.